Now let's look at example 5, finding the inverse of a radical function. Find the inverse of f of x equals 2 square root of x minus 3, and then we're going to graph both functions. So we have f of x equals positive 2 times x minus 3, square root of x minus 3. So what we want to do first is change f of x to y. So we get y equals 2 square root of x minus 3. Then we switch the roles. X equals 2 square root of y minus 3. Then we need to isolate the y. So the first thing we do is we divide by 2. So we get x over 2 equals the square root of y minus 3. Then we're going to, how do we get rid of the square root? We square both sides. So this becomes x squared, now I'm going to change this to 4, equals y minus 3. Then last, we're going to add 3 to both sides. So we get x squared, and I'm going to change this instead of over 4 to 1 over 4 plus 3. And that is our g of x. Okay, so that's your g of x. g of x equals 1/4 x squared plus 3. So what I want to do is go ahead and graph both of these functions. And so that part's a little challenging, but it's good practice on graphing radicals. So let's graph this f of x. So this is translated right 3. Okay, and so this is also, it's right 3 and a vertical stretch by 2. So remember the pattern 1, 3, 5 here. So we're still going to move that direction, 1, 3, 5. What's changing is our y values. So what that means is when I plug in, let's plug in, if we plug in 3, we get 0. Let's plug in 4, right? Because 2 square root of 4 minus 3, let's solve for that. We get 2, 4 minus 3 is square root of 1. So the answer is 2. So notice, when I plug in 4, I get 2. So I get 4 up 2. Normally, I go right 1 up 1. And then in this case, I go up 2, right 1. Now let's do another good number. Let's see, I want to get 4 inside of here. So in order to get 4, I need 7. So let's plug in 2, 7 minus 3. The reason why I picked 7 is so I can get a 4 inside, right? So this is 2 square root of 7 minus 3. So I'm plugging in 7. 7 minus 3 is 4. And the square root of 4 is 2. And 2 times 2 is 4. So I go right 7. So let's extend this graph. So 4, 5, 6, 7, right? And then I go up to 4 up here. So what I want you to notice is that we went up 2, right 1, up 2, right 3. Then the next one is going to be, what do you think? Up 2, right 5. So instead of going up 1, right 1, up 1, right 3, up 1, right 5, with this vertical stretch, we're just going up 2 instead. Okay, so just to kind of teach you how to graph a vertical stretch here. And that's kind of what I wanted to go over, since that is a skill that we need. So that is the graph of f of x. Okay, and that's how you stretch it. And now let's take a look at this function here. 1/4 x squared plus 3. So let's graph g of x. So that shifted up 3. And then we know from before I said you go right 4, up 4. But let's pick another nice number. What else would be great for x squared? Well, we want it to be 4. Ooh, so if we can plug in 2. 1/4 of 2 squared plus 3. What is 2 squared? 2 squared is 4. And 4 times a fourth is 1. So 1 plus 3 equals 4. So what I want you to notice is that we plug in 2, we get 4, which is right here. And so look at that. It's a reflection of this graph, right? The next point we could have had was 4, 4 up here. And then that would have completed that. So there is the graph of this function. All right, so what I want you to do is go ahead and try number 4 and 5. No, more than anything. Oh, one more thing I need to talk about, right? This is a parabola, and I need to restrict it. Sorry, let me go back to that. And notice, I only graphed the right side, right? I knew that I didn't need to graph the left because the pink is only, like half a rainbow, so I only needed half of the parabola. So if you notice from our previous example from before, it was restricted. So what we're going to say, and this is just a little bit more higher level, is that we're going to say that we only want the positive side of this graph. Okay. So I'm not going to ask you for this on a test, but this is technically what you have to include, is that we only want the positive side of the graph since we're only looking at a positive square root. Okay. So what I want you to do here is for number 4 and 5. I want you to try and find the inverse. If you can try to graph both, but more than anything, I really want you to know how just to find the inverse of the function. Now, these are both positive, so if you can write the restriction, that'd be great. But again, if you can just do the inverse, that would be wonderful. All right, if you tried this out, number 4, I'm hoping that you got at least this far, where you got x squared over 9 equals y plus 4, and you subtract 4. And so maybe you left it as x squared over 9 minus 4 as your d of x, and that's okay too. But this is the function here. This is what you could simplify it to. And then we know that we only want the right side, so x is greater than or equal to 0. So if you notated that, that is really nice as well. Then I graphed it. So again, to talk about the graphing, let me graph this f of x. It's vertically stretched by 3 and left 4. So we shifted left 4, and then it's vertically stretched by 3. So remember our pattern, 1, 3, 5. Now what I'm changing is I'm going to go, is my up direction. For up, I'm going to go up 3, and then I'm going to still do this pattern right. So what that means is I'm going to go from here, up 3, right 1, up 3, right 3, up 3, right 5, and then up 3, right 7. So that's how you would graph a stretch there. Now let's take a look at g of x equals 1/9 x squared minus 4. That's shifted down 4. And then actually, if you just think about it, you go right 3, up 1, right 3, up 5, right 3 up 1, right 3, up 3, right 3, up 5. So kind of looking at that pattern. Then number 5 is a really nice one. So it's just, you find the inverse, you get g of x equals x squared minus 2. And we only want that right side, which is x is greater than or equal to 0. So graphing this, we know this is just left 2. And then we just do our normal pattern, up 1, right 1, up 1, right 3. And then for this one, our parabola, we only want the right side. We shift down 2, right 1, up 1, right 1, up 3. And there's our graph.